Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my colleagues and I can relax, crack a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Peter Boeijink. Peter is the president and CEO of Xyrec, a company that is removing the paint from airplanes using lasers. Peter, welcome to the pod.
Yeah, thank you very much for inviting me.
I appreciate you coming on. I had a great time with you in San Antonio a while ago, and I
Yeah,
figure,
we have a nice location over there, and San Antonio is a good city to be. Nice Spanish original city, and good climate and a nice atmosphere, good people, and we have a wonderful robot over there.
oh, I'll
And
say, yeah, it's what, like 20 meters high, I recall.
Well, not. Well, when it is extended in its highest position, it can reach to 24 meters, which is how many? 60, 70 feet? I
Something
think
like
so.
that. Yeah, I think it's
Yeah,
times a little more than three. So-
yeah. 3.3. Yeah. Well, it's a great robot, and what we do with that robot is we are removing paint from aircraft.
Awesome.
And it's a complex issue because every aircraft in the world has to be repainted. So needs for repainting because you want to avoid corrosion on an aircraft. So it is mandatory to remove paint and paint it again. I saw that in 2008 as an issue, and we worked hard and we worked long. And in the end, we have now a robot capable of doing that. So it removes the paint from an aircraft using a laser. It's the strongest laser you can get in the market. And we use a lot of unique technology to get this laser up and running and that it can remove the paint. And we built a robot around it. So it's a huge robot where all the signaling of the laser is going inside the robot towards the aircraft. It's an amazing piece of technology you have seen.
I
Yeah.
completely agree. It was one of the coolest things I think I've ever seen in terms of just, I want to say just wild out there, engineering. I mean, I'll say some features, and if we have to remove any of this, tell me, and we can just bleep it out, but I remember, you had a laser coming from the base and then going up through all the joints kind of in the middle of the joint, and you had mirrors and reflectors that brought it through,
Yeah.
and then
Yeah.
exhaust removal external to the joint. And so, I mean,
Yeah.
just the degree of craftsmanship and engineering that goes into something like that. I mean, you know,
Yeah.
it was,
Yeah, it's amazing. The technology developed. We developed together with Southwest Research Institute in San Antonio. Great institute, by the way, and great team of robot experts they have. And when in 2020, you remember COVID time, and nobody moved anymore, but we submitted the robot as a technology innovation to the top 100 innovation award. And actually, I was expecting that we would win the top 100 innovation award, which is a competition between MIT and Stanford and us in this case. And I was expecting we getting that based on our tremendous software development we did. And we were really surprised. It was not on software; we got it on mechanical engineering.
nice. I mean, the mechanical
And
engineering in that robot is so over the top. I mean,
it's over the top. That's correct. But nobody talks about the software. But the software is real over the top here.
well, it's like the
And
part of the iceberg under the water that you don't see,
yeah,
with your
yeah,
naked eye, but it's most of the thing. So tell
yeah,
me about
yeah,
some of the software developments that you had to do to
yeah,
make that robot operational.
yeah. Think about that. You have first of all you have a robot system unique in design. So you have 8 axis robot with some of them rotational joints, some of them translating joints, and you'll have all to control it. So you need then for that we need a controlling algorithm, and so we were looking for it, and We compared all the robot controllers you can buy in the market, and we came at the end to a robot controller supplier from Austria. You think Austria? Yes, Austria in Europe. And there's a company called Kiba, and actually the company is known by specialists because they deliver an Intel-based robot controller with a Linux operating system, and on top of that, it's a full ROS industrial environment we getting.
That's cool. I bet
So
Matt Robinson loves that.
yeah, absolutely. Matt Robinson is well, he was not involved in the choice for that, but later on he learned about it and said, "Wonderful, Peter, what you're doing here." ROS Industrial is the environment in which we use to develop all the applications on the robot. What did we develop then? Well, of course, you need to instruct the robot to go from point A to point B and using the joints in the most efficient way. That was solved, by the way, by Kiba. They developed the algorithm for the movement of the joints. It's just standard stuff. Little about Kiba before I answer further the question.
Sure.
Kiba, 1,000 people working there in mechatronics, leading in power management systems too. All the Chinese robot companies, every week a new one, are using Kiba controllers.
Oh, cool.
Think about that, what I'm saying.
Yeah, those
So
guys are on the forefront right now. So-
yeah, forefront right now. Exactly. And why? Because it is very modular and open. So you can easily add software to it. So it has, of course, the safety functions that you need for robot controlling. You need the safety functions integrated in the controller. And all the application functions you can also integrate on the controller. So we have a seamless integration between functions and the controller robot movement itself. We want to have a laser on the right moment on and the right moment off. And to get that really well functioning, we have a full integrated process there on the robot controller itself. And so, and that's a very beneficial issue because you want to develop further your software in new releases. And every time you just upgrade this without the issue, will the communication still work? That's not an issue. Well, then we have a lot of sensors on the robot, and we have 700 data points we measure.
Wow.
And that's when you I'm not sure whether I showed you this part of the robot, but it was maybe closed, doors were closed, but 700 data points, and we easily monitor all those 700 data points in the sensors with the controller and the open software.
So do you have like a
environment.
hierarchical compute system then to be able to process all that, or how
Yeah,
are you? Okay, cool.
yeah. We have the open source interfacing. So all the data coming from the robot is actually in the end in the SQL database, and the job performance can be easily monitored
Oh, cool.
and easily be registered, and business analytics done on the job. It's a very fancy robot environment by this software. And when I compare that with everything what in the market is available, it's a step forward. It's operating system 2.0. It's really different from what you can get from Yaskawa or from Fanuc or from ABB. It's uncomparable.
Yeah, it sounds like it. I mean, you can't get that kind of data off a lot of that. That stuff's not typically running Linux to be as adaptive. You know, to your point about being able to monitor 700 data points, a lot of those robots are just monitoring their own joint angles.
The implementation is that way done that we have a 0.2 second delay between the US and the Netherlands, for instance. So we can easily monitor in real time the robot from here, from our head office, and can assist the operator when there is something going on in the job.
That's awesome.
And actually take over the job control at the moment it is needed.
Do you have some kind of a guide rail on that to keep you from, crashing into the airframe, for instance? Or I'm guessing that's what some of those sensors are doing.
Well, of course, the robot controller gives a lot of data itself about the positioning of the all the axes, and but also the laser system gives data. The filter units give data. The heat exchangers, the air compressor, the distance sensors, the temperature sensors,
Very cool.
the inert location sensors. All this data is collected. Video cameras integrated. All this data is collected. Yeah.
That's awesome.
And and the benefit of it, of course, is that when you run the robot for the job, that in the end the customer wants to know exactly what has happened to the aircraft, and the robot tells exactly what happens to the aircraft and how the job was performed. So years later, for instance, in an insurance situation, you can still prove what the robot did and not did. And by that, fulfilling requirements insurance companies ask us.
That's awesome.
Yeah, yeah. So a lot of under the hood here.
No, I like that. I mean, I'm all about these rabbit holes and these tangents because for me that makes interesting conversation.
Yeah. The other point of this whole software is also the orientation the robot is capable to do. So one of the issues you have is when you want to remove paint from an aircraft, the first question is where is actually the aircraft? So you have an aircraft in a large hangar, and you have a robot on the side, and now needs the robot to find the aircraft. How does the robot find the aircraft? And the aircraft is a huge machine, the largest aircraft like the 777. These are 70 meters long and 65 meters wide. So 80 meters high. So that's huge equipment actually. And now is the question, where is it actually? And I'm not talking about meters, but I'm talking about millimeters precision. So
Awesome.
we have developed an orientation system which uses passive markers on the aircraft. And we measure, with the LiDAR scanners, we measure the position of the aircraft. And which is common, by the way. It's not so new what I'm telling. When you talk about the horizontal level, that's common to know. To know in horizontal in the XY space where something is.
Really?
But the question is when you have an aircraft in a hangar, it's not said that the aircraft is actually in level, because it can hang a little on the back side, it can handle on the front side, as the landing gear can a little change. It can be hanging to the left or to the right because the wings are a little change in loading. And so the aircraft is not actually in level as the CAD drawing would provide. So how do we find the reality to the CAD drawing? And we measure the aircraft in 3D, the position of the aircraft in 3D, and we do it continuously. Because in the real world, the aircraft changes its position in time by temperature changes and by humidity changes in the hangar itself. So you see a lot of issues there around on to have a real aircraft and a real robot having 1 millimeter precision while you approach the aircraft and using a large laser to remove paint from an aircraft. Not hitting the windows, not hitting the doors, not hitting the Wi-Fi antennas, etc.
That's incredible. When you talk about passive markers, are you talking about just the characteristics of the airframe or something you attach to it in order to be able...
We attach to it. We attach a kind of reflective material.
Oh, cool.
And very, very specific designed, in common for all the aircraft. And by gravity, it hangs on the aircraft. And we can see this reflective material and interpret by that where the aircraft is exactly and how it is positioned in space.
Awesome.
Yeah, yeah. Oh, that's one example of the kind of software we are all running on this robot. Another interesting aspect of the software we're running is that when you want to remove paint from an aircraft, you want to be sure that you are doing not too much. Because when you try to remove too much, you have to risk that you damage the aircraft. So you want to control the process. And how do we do that? We are making pictures while we are moving with the laser over the aircraft. We are making pictures while we do that, and we're making 800 pictures per second.
Wow.
800 per second with two cameras, a visual camera and infrared camera. And the 800 pictures, we analyze them in real time. And in real time, we use an AI implementation because we learned previously the software, what is the goal state we want to have? And then the AI decision algorithm gives the instruction to the laser system how much energy we want to have on each spot. And
Cool.
that's all happening in real time.
That's incredible.
Yeah, it's amazing. And I in my background, I studied actually artificial intelligence for my master in computer science and mathematics, and in the 80s, by the way. So
Nice. Before it was cool.
before it was cool, exactly. That's a good remark. And we are really fond of that. We have an AI implementation running on our robot in production, in a really production system.
That's
Think
incredible.
about that. Yeah,
I am. And so, like, for me, what's really interesting is that it sounds like you're trying to straddle this narrow line of heating the paint up so much that it evaporates and you can suck it up through an exhaust system, but
yeah,
also not trying to heat up the epoxy that's holding together the composite, which makes up the airframe. And so, like, it seems like a very narrow band for performance that you're trying to hit there.
exactly. And it's so it needs a high quality process control, and computer can do it. The AI
When I'm,
implementation can do it better than humans.
when I'm
So
guessing
we
that
are
the infrared camera is doing the heaviest lift there too. I mean, because that's where you're getting your temperature data from, right?
it's just to collect more different data points, and how more data points we have, how better we can control it.
Did you know that Collaborative with Spencer Krause now has a merch store? Please go to cwskmerch.com for the latest in CWSK styles. You can get a hoodie, like the one I'm wearing, t-shirts, hell, we even have whiskey glasses. Everything in the store has custom art that our team worked really, really hard on. So go ahead and show your support for them, me, and the rest of the CWSK team by going to cwskmerch.com today. Better yet, support yourself and use discount code podcast10, all one word, all uppercase, for 10% off your entire order. Thanks for your support and enjoy the rest of the show.
The business case is fantastic. It was originally designed and that we would be at least the same speed as the current speed. Currently, it's the paint removal is done by hand, by chemicals, and then washing away the chemicals, and all the composite part on the aircraft are all hand sanded. Think about it. A 787 hand sanded.
That sounds
2,000 square meters. It is about, what is it, 200,000 square feet? 200, 2,000, no, 20,000 square feet, about 20,000 square feet, hand sanded.
Right the circle, left the circle.
that's insane.
Think about that. Think about that. You are 27 days. From the 27 days, such a job is about 20 days they're hand sanding an
How many
aircraft.
people are hand sanding? I mean, it must be.
16
Yeah, that makes sense. That sounds about right.
continuously
Yeah.
in two shifts.
Well, at least
16 hours per
3M
day.
is selling a lot of respirators to that crew. So-
It's good business for the respirators and all the PPE stuff you need, because it's
oh, and you need
very,
it. Like you need it from the dust from sanding, and from the
Oh,
the chemicals, like you mentioned, the solvent bath they use to pull it off.
all the stuff you see what in paint is, you're getting sick. You're getting really sick when you are doing that a couple of weeks without protection.
Yeah, I would
Actually,
imagine even with protection, like it's probably still like gets to be a lot. I mean, and
you cannot inhale it, but you cannot have it touched on your skin. You are maybe familiar with Chrome 6. Chrome 6 is part of paint to avoid corrosion. Chrome 6 is people getting cancer over it. It's
brutal.
terrible, terrible chemicals in paint. So this robot is taking care of all this stuff, but it is at least 50% and actually up to 75% faster.
That's
And
wild.
every day in aircraft on the ground is dramatically.
So it would
for
take a
the-
32-person crew to be as fast as that single robot.
Yeah,
Yeah,
Yeah.
that's wild.
yeah, yeah, yeah. It goes from 27 days. A job with robots goes down to 6 days.
Nice.
6 days.
Wait, how do you? I don't get it. If you're 50% faster, wouldn't that mean? Is that just
13?
because you? Yeah.
But it is up to 75, I said.
Okay, I got you.
It depends a little on the type of aircraft. On a 787 and a 350, Airbus 350, it's about 75. And on a 777, which is much more aluminium aircraft, you talk about 50%.
Oh, that's why is that? That you have more efficacy on a composite
Well, the
frame?
the way of removing paint on aluminium is using chemicals. So
Yeah.
they spray chemicals and they wash it off. So that's a faster process
I see.
than hand sanding.
That makes sense. But with
Yeah.
composite, you have to hand sand because the chemicals would dissolve the composite matrix as well as the paint.
It's they try to do it with chemicals, but that's not very successful because then you need to add a special paint to it, which is then harden it to avoid that the chemicals is removing that kind of paint. So it's not a no solution actually. And so the robot is well positioned to take over all this work. And we're talking about the robot removal, but the first thing I can tell you, what the airliners are telling me is, Peter, you have a robot for removing paint, but what about painting then? Are you also doing this robot? So the robot you saw, it stays the same. You take off the laser, we add the paint equipment, and we have a paint robot.
Nice. That's awesome.
I had yesterday a guy who said, Peter, is it not true that painting actually is more simple than removal with a robot? I said, yeah. The guy was a financial guy, so I was amazed about this question. And I said, oh yes, absolutely. It's much easier to have a paint robot than a removal with a lift. I said, great question. Great question. Now he was right. He was absolutely right. Paint robot is actually easier to build and to construct and to assembly.
But I would imagine a lot of those algorithms are applicable as well. I mean, if you're already traversing the exterior of the plane, I mean, it wouldn't be that
You're
much
absolutely right. That's one of the reasons why we don't have a lot of work, because the software stays the same, about the same. Only, of course, starting the paint gun, ending the paint gun is different from starting the laser, ending the laser. But that's the difference. But that's it.
Nice.
There's not more to that actually. And so we expect that we can our second robot, and maybe you are getting involved in that.
I would love to.
Who knows? And that we are getting it in 26. We will have a paint robot.
I'm excited to see it and maybe even work on it.
Yeah, love to. No, you have a good technical people behind you also, and
thank you, Peter.
love to work with you.
Yeah, likewise.
Looking
I really appreciate that. I've worked really hard to build up a good team, and I'm proud of all the work they do, and I'm grateful to get to work alongside every one of them.
Yeah. Only thing is that they need to love to work in San Antonio. Is that okay for them, you think?
I think it probably depends on the person. I mean, we've got folks on the team that would never leave Silicon Valley. So we have them work on projects in Silicon Valley and remote ones.
Yeah.
We have folks on the team that would never want to leave Pittsburgh, but those people can do good work in Pittsburgh. So it just depends, right? I mean, you select for that. So, it's a constraint, but it's not an unsurmountable one. I mean, there's people, that are living in different cities, to work on things right now that are on our team. So, you kind of ask them and you see, hey, particular engineer, technician, what do you think about this? And they say yes or no.
In the end, it is a project, of course. So there's a beginning and an end date, and so that's good news for people, for family life. There's a beginning and end date, and I think it will be very interesting because the thing that you're doing is you built a huge robot.
Yeah, for sure.
A real aircraft. That's something.
And I don't think I've seen many huger robots. Like maybe the Xyrec one that lays down tiles on the bottom of the river in New Orleans. The Army Corps of Engineers one, that big yellow machine. That might be the only robot I've seen that's larger than the Xyrec robots. So,
Okay. All
but
right.
it's
Oh, I mean, we are not we don't have the largest robot in the world, you think?
I
Oh.
don't know. I mean, maybe by height, but like
Oh,
by just
yeah.
sheer volume, I think that one might be
Okay.
that might be the largest robot I've ever seen. So,
Okay. It's okay.
yeah.
As long as we are the champion in height, then we are okay.
Well, and also awesomeness. I mean, it's got a giant laser on it, and like the engineering is incredible. I mean,
It's
the way that you, like I said, pass laser energy through the center of the machine while exhausting in the exterior is very interesting to me as an engineer. I mean,
yeah.
it's one of those machines that you kind of wish you got to work on.
Yeah, I can tell you that we are this is just one of the projects with the paint robot, but there comes up a new one also. New thing we are working on is to solve an issue with airplanes. And one of the issues is that you like to have less fuel consumption on an aircraft. You can understand. When you are able to reduce the amount of fuel consumption on an aircraft, you are in great business model is that. So how do we do that? How can we do that with a robot? You can change the outside of the aircraft. We can add, we call it the shark skin. Shark skin is a famous title for the issue that they found out. Why can sharks so fast swim? Well, the reason is the skin. It's the design of the skin. There's a certain structure in the skin, and by that the friction of the shark in the water is less, and by that it can swim faster. Well, the same is going on with aircraft. When you change the outer structure of the aircraft, you can change the friction in the air, and by that we have reduction of fuel. So we work with a Japanese party together, and they have found a way to make microstructures in the outside of the paint of an aircraft. Microstructures, we talk about structures of 50 micron. You cannot see it when you see it. Normal colors of an aircraft, you don't see it. That you have such we call it riblets in the paint. And but we are able to make those riblets with our laser robot. So you can expect that at the end of 26 we have the same laser robot which can remove paint, can also create riblets, shark skin on an aircraft.
So that has to be directional for that to work, which is you can only do that with a laser.
The only solution to do it is with a laser. That's correct. It's very strange in which direction the riblets are oriented is not that much important.
Oh, I did not. Okay, why? And how does that work?
It has to. The reason then you have to go into why an aircraft actually has friction, and we talk here about friction, skin friction. You talk about. You're not talking about the friction of the aircraft has to push away the air molecules. You have the friction, which happens when the air flows over the surface of the aircraft. And when you have airflow of the surface of an aircraft, you have automatically very small turbulences. And you cannot see it by eye or so. You talk about turbulences in a millimeter level. And these turbulences are the friction generating. They generate friction. And when we make the riblets in the paint, you have less turbulence on the surface of the aircraft.
That's interesting.
You know it yourself actually from turbulence in when you have a water tap in your kitchen and you open the tap more and more, then at a certain moment you see that the water come out of the tap, you see that the water is not more smooth going. It's getting a kind of turbulence in the water.
Yeah.
That's the same thing happening. That's the same thing. It's known already, mind you, it's already known in 1880. It's in Europe, and the scientists found out that with a certain speed of water, you get automatically turbulence. And everybody says, why is that? They could not explain it, why it was, because there's no reason. It was a flat surface. your inside of your tap is flat, huh?
Yeah.
Copper or plastic or what else it is, and it's smooth.
Well, I'd imagine it's occurring
And
outside of
still
the
it
tap,
has,
like between the tap and hitting the ground, but maybe I'm wrong.
yeah. Take it next time. And when you come home, you look at your tap in your kitchen and you look at it carefully and say, "What alert from Peter is when I doing the volume more open and we're getting turbulence in the water." Look at it,
Yeah.
and
Yeah,
then
I'm
you
gonna
say,
check that
"Oh,
out.
hey, this is funny. This is something which is somewhere created in the waterline. Uh, while the waterline is smooth, it still creates turbulence with certain speed." Now, it's same happening with aircraft flying in the air. With certain speed, we're getting turbulence on micro level on the surface of an aircraft. And to get rid of that, you have to create riblets.
That's wild that works.
Yeah,
Just 50
yeah,
micron deep, 50 micron across, or does it?
yeah.
Okay.
It's a 50 micron wide from each other, the riblets. And each riblet is about 50 micron high.
Cool.
Yeah,
And it does
yeah.
not matter the direction at all, because I would have
Doesn't
thought
matter the
direction of the
direction,
plane,
no.
but that's just
Yeah,
me being
no,
naive.
no.
Yeah.
No, just how the air molecules are getting attracted to the how they touch the riblets, and when they touch the riblets, they are not going into turbulence.
So in theory, if you put that on the inside of your faucet on your sink, you, you can get rid of
They do
turbulence
that.
there.
They do that. They do that. They don't do it, of course, for household applications, but in energy applications, in Shell, and all these oil companies, they have this issue in when they pump oil or water or any other stuff through a pipe. They have the same issue. They have
And
the
that's
issue
actually
that
been done where
they're
you can
getting
coat the inside of the pipe with.
yeah,
Okay, that's
yeah.
wild.
Yeah, they try to solve that issue when they don't want to have turbulence in the pipe itself.
Okay, so it occurs inside the pipe. I'm wrong,
Yeah.
thinking that it occurs in the air out. Okay, that's interesting.
That occurs in the pipe, in the water line coming to the faucet.
Yeah. The more you know. I feel like I'm learning so much in this conversation.
Well, I just read this and I say, oh, can I repeat it to Spencer? Yes, I can repeat it to Spencer. So hopefully.
Well, that's one of the things I love about recording this is I always just learn so much, talking to people that are smarter than me in different ways, and so.
Well, I think you're your own here. Yeah, doing well, I think.
Thank you, sir. I appreciate that. I'm just a lowly roboticist. So.
Yeah. So upcoming in end of 26 is a feature where we can create shark skin on an aircraft, and that means that we're going to introduce in a standard job aircraft which are reducing the fuel consumption up to 4%.
Wow.
And that is huge. This is huge. What I'm saying.
Yeah.
When you understand that
that's
spend
a huge
yearly
part of the cost of running an airline is the fuel cost, right? I mean, that's.
Yeah. The DoD, the U.S. Air Force, and the Navy Air are we calculated for them what they would save, and we talk about 100 million a year on fuel cost.
Just for the U.S. Air Force, or for the U.S. Air Force plus the Navy?
I think I did a calculation. I think it's based on the fuel consumption from the Air Force.
Wow.
Air Force.
Even still, though, I mean, that means they spend what, $2 billion a year on fuel, if I'm getting that right?
Oh yeah.
That's so much money.
Yeah, but I look at how many aircraft they have and what they do.
Yeah, it makes perfect sense. I mean, and
they fly around the world and then they're flying back. They're doing something somewhere in the world and then they're flying back again. What do you think what happens there?
Yep. Yeah. Guess it takes money to do that.
Yeah, absolutely. But it takes a lot of fuel.
And as a taxpayer, I'm saying, why don't we have these riblets yet?
Yeah, you are the taxpayer, so you should say to your somebody else, your Congress lid, and saying, we want fuel reduction on aircraft. I learned that it is possible.
Yeah. I think I might next time I talk to a congressman or a senator. You laugh, but we had a congressman by our office like about a year ago. So.
Okay.
I think it'll happen again.
You understand that this is something which is heating up also in the DoD organization.
Yeah, for sure. Well, I mean, again, like I kind of joke, but I really do mean it. I mean, as somebody who pays taxes and wants the money to be used efficiently, I mean, that sort of thing is important to me.
I think in the current atmosphere, what is running in Washington is this is a great understanding that operational excellence is, of course, in the middle of the attention now, and everybody wants to use the money better. The DoD has a huge budget, and everybody is asking the question: what do we get for that money, and do we get enough? And well, I'm not a U.S. Citizen, but we pay company tax in the U.S., so we are interested also in that the tax is well used. And
yeah, of course.
So I'm interested that DoD is using the money wise and efficient. So it's sometimes you want to hammer somebody on the head and say, "Listen to me, do it more efficient."
Yeah, no, for sure. I completely agree.
I leave it to the people in Washington, and I'm a very modest and humble traveler in the U.S.
Awesome. Well, hey, happy to have you in the U.S. When you're here. It's nice. I feel bad. I haven't said this on the air, but we scheduled this with me thinking that Peter was going to be in San Antonio. And so I put it later than I normally would to try to be nice and have an an after hours time in Texas. And then I found out you're in the Netherlands. And so not only is it not earlier here, it is 6 hours later than it is here in Pittsburgh.
Yeah,
so
it's not 2:00 here.
Yeah, I feel terrible.
No, but I'm good. I have daily calls with the US, and I'm used to stay up late. And thank you very much for the invitation to comment in your talk show. Yeah.
Oh yeah, my pleasure. I'm happy to have you. It seems like a good note to kind of wind down on. So I guess as we're nearing you having to get to sleep and also the end of the episode, is there anything you want to plug? Anything you want to leave our visitors with or talk about on the way out?
Yeah, let's plug that. We read all kind of things about the US and the world, and let's not get the eyes off the ball. The eyes of the ball is we have to make progress, and when the progress is by working together, countries are working together, companies are working together. That's the way how to do it. And in the end, everybody will be successful in this, and the US will be successful, and other countries will be successful. That's all is good. I love to get engineering done in the US. I love to have customers in the US. I love to be in the US, and let's make this successful. And hopefully we can work together, your company and my company, and see how the future, which is bright, can make more bright.
I couldn't agree more. And that is such a beautiful message, I might add. You know, we're stronger together than we are apart. Peter, thank you so much for coming on.
Absolutely. Okay. Thank you very much. That's it.
Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause can be found on YouTube, Google Podcasts, Spotify, Apple Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.